For many years in sci-fi media, we've seen the idea of a technology that would allow us to travel faster than the speed of light to other stars. In Stargate SG-1, there's the Stargates. In A Hitchhiker's Guide to the Galaxy, there's the Infinite Improbability Drive. And in Star Trek, there's the Warp Drive. Now, for a while, this was thought to be purely science fiction. Surely nothing can go faster than the speed of light. However, modern physics seems to suggest that this warp drive is actually possible. Einstein's theory of relativity tells us, A, that nothing can move through space-time faster than light, and B, that the presence of energy warps the fabric of space-time around it. Well, in 1994, Mexican theoretical physicist Miguel Alcubierre, in his paper, The Warp Drive, Hyperfast Travel Within General Relativity, proposes a method by which superluminal speeds could be achieved. In this Alcubierre drive, as it's come to be known, space in front of the drive is contracted and space behind it is expanded. This creates a bubble. This bubble can move faster than the speed of light because the speed of light does not apply to the expansion and contraction of space-time. It only applies to the motion of objects through space-time. So, this bubble can go faster than light. Additionally, an object can remain inside the bubble and not be breaking the speed of light because it's not technically moving faster than light relative to the space around it. Locally, it could be at rest. It could be sitting still in this bubble, so it's not breaking any rules. Now, originally, this drive was thought to require an insane amount of energy, not something we could ever do. However, as is discussed in the article, warp drive may be more feasible than thought, scientists say. Dr. Harold White at NASA has found a way to lower this energy requirement into the realm of the feasible. Now, surely this is just theoretical nonsense and isn't actually possible, right? Wrong. We've already seen a similar phenomenon occur in our universe, and that's the width of the universe, specifically the observable universe. The observable universe is 93 billion light years across, approximately. This means an object traveling from one side to the other at the speed of light would require 93 billion years, but the universe is only 13.8 billion years old. So how can the universe be this wide? Well, this means that the universe has to be expanding faster than the speed of light. This is discussed in the article, How Can the Fabric of Space-Time Be Expanding Faster Than the Speed of Light? By Ethan Siegel. He's a physicist. And basically, what the article points out is that the speed of light does not apply, again, to the expansion or contraction of space-time. It only applies to the motion of objects within that space-time. Now, this type of motion certainly has some benefits. Obviously, traveling interstellar distances that's an obvious benefit. But one that's not probably considered by a lot of people is time dilation. If humans were to build a ship that allowed us to travel 90% of the speed of light, that would allow us to travel to other stars, to people on the ship in low times. But once you got there, people on Earth, due to the extreme time dilation, the people you knew would be dead. However, this warp drive, because you're not moving through space at a high rate, technically. Space is moving with you in it, but you're not moving through space at a high rate, at a relativistic speed. You wouldn't experience time dilation, and approximately the same amount of time would pass for you as it does for people on Earth. This is discussed in the paper, The Real Warp Drive, or the article, The Real Warp Drive. This is an obvious benefit because we could go to other stars and come back and, people we knew would still be alive. Now, this might sound too good to be true, and, there are some real difficulties with it. For instance, the main issue is this warp drive technology requires the usage of exotic matter, which is basically matter with negative mass. What we need is a way to have negative energy. Now, we do know that at the quantum level, we can have a region of space with negative energy density. That's the Casimir effect. So that does inspire some hope that this is possible. Another issue is, when the drive comes to a halt, any particles that were picked up in front of the bubble would be launched with extremely high energy, and they would just decimate anything in their way, including entire planets or solar systems. Now, despite these issues, NASA has chosen to research this technology at their EagleWorks laboratory. And this inspires hope that one day humans may be able to colonize the stars. And here is it's not exactly a note card, but it's smaller than one, so